All right, welcome to customizing your Emacs. So I thought I'd get started by introducing myself, a little bit about me. My name is Caleb Ayew-ew. If you're up on your phonetic alphabet, I put that in there for you. I started at Configura 2011. Fun fact about myself, I prefer Cherry MX green switches for no other reason than that they're green. Just kidding. But anyway, my time with Configura, I've been production team focused, mainly the office furniture, commercial interiors, whatever. I helped develop the abstract labs on top of the kitchen abstract, and now I'm scratching the surface of material handling. Also, I have used Emacs for close to 15 years, starting in university. So I took an AI class back then, and the professor was really old school. He talked about how he had punch cards, and he would wait in line to register his punch cards and hope he didn't have a bug that day. But anyway, him being so old school, he required everything to be done in Emacs, including submission of homework. So he developed this entire suite that had automatic grading. It kept track of attempts. It was tied to our university account, and it was all written in Emacs, which I thought was pretty sweet. So that really piqued my interest in Emacs as a whole. So if you weren't aware, Emacs Lisp or eLisp is used for implementing most of the editing functionality built into Emacs. So it's basically just a dialect of the Lisp programming language. That being said, Lisp as a language is sort of an acquired taste. So I remember working some assignments late at night, and I always knew, even if I was staring at the back of someone's head in a lab, I always knew that someone was in the same class that I was, because at some point during the night, they would lean into the computer screen with their finger pointing, and they were counting the parentheses. So hopefully eLisp won't turn you off from customizing Emacs, because I personally think it's a lot of fun. So today, we're going to be talking a little bit about vocabulary. Because Emacs's first release was in 1985, some of the terms used aren't so modern. So we'll cover some of the common ones. We'll go over some setup for customization. We'll cover CET operator's role in this initialization, an eLisp functions crash course, and key bindings, creation, and information around that. Themes covers themes as a concept, along with implementation, how to create your own theme, and the CM's layer of complexity for themes. And finally, getting Emacs to do stuff within CET Designer through use of CM code. And I will give some common actions that I do on a daily basis, along with some ability to override the default CM Emacs functions locally and consistently. But before we begin, a brief disclaimer. I cannot be held liable for any such problems, including but not limited to floating text while text on white backgrounds, tetra-shaped anomalies, getting stuck without your gear on the other side of a bad FTP, non-golden ratio window splits, being eaten by a GRU, delusions of grandeur due to newfound control, or any other such problems that happen during the course of this session. Let me check the participant list here. Okay, doesn't look like anyone has left. So, seeing that no one has dropped off, let's get started. Vocabulary. So first up, let's talk about frames. In this image here, I've highlighted some of the UI elements here with color coding. Frames is what we refer to as in the common tongue anyway, as a window. Microsoft Windows anyhow is what they refer to these frames. A frame can contain multiple it contains all the elements from Emacs and can be multiple of them. So like this. Windows, these are the partitions within a frame. Also multiple are allowed, and the default is known in CM land as the split 3 compilation. And that is a compilation and a split. A buffer are what we refer to as a buffer is basically just the contents of a window. Most commonly, there is a file backing it up, but there isn't always. For instance, the scratch buffer or the compilation buffer. Basically, a buffer is just stuff, and the window is the view into that stuff. And then down here in this purple is known as the mini buffer. That's essentially a special window buffer pair where you can input commands. There are also things called modes. Each buffer has exactly one major mode. Major. This dictates how commands will interact with the buffer based on anything really, but file extension is most common. And then there is also minor modes. So each buffer can have any number of minor modes, and minor modes, in my words, basically add flavor to a particular buffer. And font lock mode is a minor mode that we will talk about later. So now that we speak the same language, let's get into some customizations. Init files are intended to contain the function specific to your Emacs installation. If you've never done any customization, the first steps are to determine where you would like your initialization file to live. Natively, Emacs looks for these three files in this particular order. And if you want to use any of these, that's completely fine and up to you. But CET operator allows you to set up what we refer to as the Emacs settings.el file. This file can then live in your personal repo on Git. This is the way that I would personally recommend doing it, since you don't have to do any manual file operations if you decide to switch machines or get a new machine or something like that. There are other ways of, handling version control for your init files, but since operator already has a way, why not use it? So to allow for Emacs settings EL, really all you need to do is open up your operator and click the Emacs dropdown and then check Emacs settings. What that will do is open up this dialog, and then under the advanced settings section, you can check the Emacs setting file right here. So if you haven't done this before, operator will create this file for you within your personal repo in your profile subfolder. While we're here, it's worth mentioning the different things that you can do in this dialog as well. If you are in a QA role or if you're in a QA role or a non-developer role for some reason, you can turn on the Windows short keys. This basically replaces the Emacs key bindings with Windows 1. For instance, you can replace your yank, which is Control Y in Emacs, with the Control V, which is paste from Windows. Ayew mode is fuzzy logic autocomplete searching. A toggle for this mode exists here, which newer developers may not have ever even noticed this, but this is an option for you. If you don't like that fuzzy logic searching, you can turn it off through operator. And you can even set up Emacs key bindings for operator related tasks. And shown here are the defaults. So let's talk about what those are. The first one is browse to file. So when you are in Emacs and you run that browse to file, which is default Alt-O, it will open up the Developer Studio pointing at the file that you are currently in. The new file dialog, which is this guy here, will open up this one, and you can create new files, new extensions, even new packages, basically anything that has a template, boilerplate code that we can insert for you. And then the final one, which is the show find and files dialog, it will open up the find and files dialog within that subfolder that you are currently pointing to in your Emacs. So I use that one quite regularly. So those are the functions that Emacs key bindings that you can control from operator. There are also font settings and frame positioning. It says window here, but they really mean frame. And then window split options, and that shows that default 3 split that I mentioned earlier. You can also tell operator what your username is, have it generate a T file for you, which is for testing, and you can even store previous sessions of Emacs just by checking that. And then there's also arbitrary commands that you can run for command line, starting it up. And you can also preview your Emacs changes here, which is great because, like a good developer, you should already have an Emacs version running. This will not mess up anything you have going on. So kind of handy. So those are the Emacs settings we can change through CET operator. So now we're going to start talking about defining eLisp functions. What I've shown here is copied right out of the GNU. I know it's pronounced new, but for clarity, I'm going to say GNU, the GNU Emacs manual. So defining a function is actually pretty simple. You basically need to, write out def fun, a function name, arguments. So the documentation, which is a string. So this describes what the function is intending to do. And then there is declare. So this is kind of like metadata for that function. So if you have a deprecated function, you could put in that information here with another string. But in this example, I've left it out. And if you intend to ever invoke your function through that mini buffer with meta-x, interactive must be used. Otherwise, it will not be recognized as a user interactive function and only callable through other eLisp functions. So you'll see that right here. So with the interactive portion, you are able to define even how to interact with your function. So if there's like user input or extra arguments, but for the sake of time, we will have to leave default interactive since we don't have any arguments for this case. And if you want more info on that, you could read about that in the Emacs manual. For quick access to a new function, we can actually put our cursor directly, we can put this function directly within our Emacs settings file. So once we write out a function, it can live in our Emacs settings file. And then this last line here is not actually part of the function definition. This is actually Emacs nomenclature for evaluating command in Emacs. So basically this is saying, when I call this function, what does it do? So when calling jump 10, it will go to 10, the line 10 in the current buffer. So be very, very mindful when you are naming functions in Emacs because it will override anything with no hesitation or fear, and the last defined function wins. So nobody wants unintentional loss of functionality. So keep that in mind when you are creating new functions. So after I define the function in an EL file, I want to load it into Emacs. You can actually evaluate this by putting your cursor after the last parenthesis of the def fun. And then you would execute Control X, Control E. This is a lot like running a line of code within CM with that control meta space. The difference here is it now is defined and accessible by Emacs versus just running it once. And now that our def fun is evaluated, you can call this function anywhere by using meta-x jump 10. So that's a simple function here. And looking up a lot of the functions within Emacs, yeah, there's a lot of stuff that you can do and essentially script. So let's talk a little bit about key bindings. Listed here are the elist functions you can call to reduce key bindings. The first ones define a specific key binding for a specific key map. This is useful if you have, concurrent key def maps within Emacs that you are manually keeping track of, but most people don't. But I've given it for full completion. Um, the local set key and local unset key will define a key binding for a particular buffer. So this is just buffer level definition of a key. And most people really want a key binding to do the same thing no matter what the buffer. So that's why I've bolded this global set key. What this does is defines a def for all buffers. And when you place this within your init file, it will be across all instances of Emacs so long as your init file is there. And this global set key will be used in the upcoming examples. And the unset you can obviously use to unset a key binding that is defined globally. So let's break down the key binding arguments a bit. Before you can bind, you obviously need to tell Emacs what key you intend to use for your keys. So how keys can be represented in Emacs can be either a string or a vector, but luckily we can ignore both of those representations by using a built-in macro, KBD. Basically, this allows for human-readable key commands. So for instance, Control-C, Control-M, Control-Shift F5, meta hyper home key. So a quick refresher, capital C is Control, M is meta, capital S is Shift, H is hyper, which I defined on my system to be the left Windows key. And then there is also another modifier, lowercase s, which is super, which I don't use. But all in all, we have 5 modifiers that we can have for key commands. It's pretty nice. So that is the key portion of the argument. And then there is a def portion. So this is essentially the function that you want to run when those key commands are pressed. For example, we have the jump 10, could be def. From the previous slide. You can call CM specific functions. So the CM clear compilation buffer, which I know a lot of developers use. So quite regularly, why not make a key binding for it? And then also you can create Lambda functions if you don't want to go through the process of defining one. You can create a Lambda and just throw that in there. And then this one will actually just insert the word FizzBuzz. So it's kind of nice. So altogether, what do we do? Here's a full key bind command. I've bound it to Control-Alt uppercase J. Alternatively, we could have written the command with the explicit Shift key, like so. But I personally try to keep character count minimal when writing Lisp. But really, either way is acceptable. That's just personal preference. And some of you might have noticed on the last slide, the single quote here. That single quote is actually shorthand for the macro quote some argument. So basically what that is saying is do not evaluate jump 10. I mean the name jump 10 or the symbol jump 10. Without this single quote, you would actually evaluate it when this was evaluated, causing you to go to 10. So yeah, that little handy shorthand is pretty important. So a few tips when you are creating your own key bindings. much like defun, creating a new key binding will wipe out what was previously there. So if you have these defined in your Emacs settings file, be aware that that file is most likely loaded last in the chain. However, this can be used to our advantage because I'm probably not the only one who hit Control-Alt-O. If we aren't intending to be a key binding killer, how do we ensure our new binding is not about to clobber something that we actually care about? Control-HK. This key command in Emacs will tell you if some function definition is registered to it. So basically Control-HK, type in a key command, and it will spit out the function that is bound to that particular key command. You can even list out every single known key binding with Control-HB. This I typically use if I'm creating a new key binding and have want for inspiration. I can then group my new key binding with like functions, or really whatever. And help. On the last slide, I showed the help command, Control-H. If you're not familiar with this, I would suggest relying on it for investigating really anything Emacs. If you're not sure what it can do, you can use Control-H ? This command is the Emacs help's help. This will display the list of help commands. For example, Control-HK will show in this list that was shown on the last slide. But here are a few other ones that I'll highlight for you. Control-HA with a pattern. This is handy to try and find a function that you might have an inkling of a name for. For instance, we know Control Y is yank. We can do Control Y to yank, and we can search for yank and find out all of our functions that have the word yank within it. Control-HV with a variable name. This displays the given variable and its current value along with any documentation. So this is nice if you're investigating a particular variable, you know exactly what it is. And then there's also Control-HF with a function. This will display the documentation of a function. So if you know the function name already, you can use this to read up on that particular function. So to recap what we covered for the basics, initialization with preference of Emacs settings, how defun can be used to make new Emacs functions, how to create new key bindings, and how to look for things in Emacs when we don't know where to go. So let's jump into some theme work. The most prevalent question that I have from people getting started with Emacs is, how do I change my theme? Well, I really wish that I could just tell them to download some theme EL file and find a color that speaks to them. But while that is possible in most flavors of Emacs, being within the Configura ecosystem, it requires a little extra finesse. And on top of that, I wouldn't be able to sleep at night knowing that I didn't teach this new developer how to. But before getting into what a theme is, first we should answer the question, how does Emacs apply text formatting? Kind of alluded to this earlier, being a minor mode, font lock mode. So you can read all about this with that newfound Control-HF command. But to summarize, font lock mode is a minor mode that scans the buffer and it applies faces to patterns that it matches. So what is a face? A face is Emacs nomenclature. Basically, it is a set of attributes defining a text style. That style can include height, foreground color, background color, weight, italics, etc., etc. basically anything that would go into text. So then let's answer that question, what is a theme? A theme is therefore a collection of face variables that are provided to font lock mode. Easy enough, right? So the patterns that I talked about a little bit earlier, those are actually provided by the major mode. You can define patterns yourself, but eLisp regex would definitely eat up way too much time, in my opinion. So we're just going to assume that the patterns are already well defined for us within our major modes. So how does font lock mode work? It stores the list of faces in a variable called font lock defaults. And that is per buffer. So then the major mode will populate this list with its faces when font lock mode is initialized. So remember how I said we're in the Configura ecosystem? That's important because the CM Emacs integration repurposes C mode, which is a major mode. C mode stores the variables in 4 distinct A-list variables. So if you're not familiar with what an A-list is, it basically stands for associated list. For the sake of this presentation, you can think of it as a map. C mode has named these A-lists appropriately. C font lock keywords 1, 2, and 3. And then also a generic C font lock keywords. So not really much imagination. It doesn't exactly tell us what each of those lists are intended for, but they at least provided some nice documentation for us. And I'll recap that real quick. List 1 is intended for minimal font locking. For example, preprocessor directives, which is, as far as I know, irrelevant to CM. There's list 2. This is intended for fast and normal font locking. For example, keywords, simple types, basically anything that's easily recognized by a pattern. And then there is also list 3. This is the accurate normal font locking. And then this is extra, like I mentioned, and that's intended to be populated by whatever. But CM actually utilizes the third list because it is supposed to be the most accurate of the bunch. And CM mode adds to this list its own face definitions. Since these are simply variables and Emacs doesn't really care about anything but recency, you may have guessed that the faces can be defined really, really anywhere. You could have arbitrary code, in an EL file that you got from some package that injects faces into one of these lists, and Emacs doesn't care. This is why it's not as easy to tell someone to go and download a theme from the internet. Because if they don't apply a theme that overrides the custom pattern face set up by CM, then there's really going to be a mixture of faces, and the theme isn't going to look exactly how they want it or how they saw it on the internet. So most of the CM default colors can be found in this file here. This is in base Emacs CM font lock colors EL. So that outlines the problem with an arbitrary theme application in CM. However, there is a solution. We are able to get a full list of our faces for our current buffer using our good friend control HV with that variable font lock defaults. So if you run this command, you'll see it spit out the 4 lists from C mode. And those lists are actually where the actual pattern value pairs exist. So let's take a look at that list now. 1 sec. really cold in here, so it's like my fingers aren't working like they should. So if we do Control HV, font lock defaults, you can see here that the value of this list are those three, right? So you could do another Control HV on these guys, and it would spit out the actual faces, but that also includes the patterns, and it's really hard to figure out exactly what is going on here. So luckily, I made a function that, let me close that out. I made a function here called print values of a list. It isn't very robust, but it does the job. Remember that these font lock defaults are buffer specific. So if I were to run this function in this EL file, I would get different results than if I were in a CM file. So we need to go back to our CM file. And basically what this does, it will, if I put my cursor here, Control X, Control E, what it will do is spit out the unique faces from this buffer for CM. So now we have all of these. We have all the faces that CM is utilizing for any given CM buffer. So what can we do with that information? Well, remember those faces are what makes a theme. So we're going to use those later to create a theme. Now it's time to create it. So knowing all of the faces that CM is utilizing, we can pull up this information here to define a theme. So there are 4 functions that are of concern when defining a theme, and I'll provide the signature for each of them here and do a short walkthrough of each. The first one is this def theme. This adds the theme to the list of custom themes. In other words, it tells Emacs that it exists. I typically give a little more verbose theme name within the doc, which is that string that is documentation for a given theme. So for instance, I have a theme called rose-colored lens. That would be a string here. There is custom theme set variables. This defines theme-based variables. So variables that are specific to a theme. For example, ANSI colors for using some of the colors from your theme in like an 8-bit terminal or 16-bit terminal. So yeah, I don't know many of you doing terminal work, but it's there if you need it. Custom theme set faces. This function does the bulk of the work. This is the definition of the face variables that we talked about. The arguments here have the type face spec, where face is that symbol we printed out in the scratch buffer. Spec has a form below. So this states how the face should appear on different kinds of terminals. But we can have all our attributes, the height, the weight, etc. Display for all terminals by simply putting in T for display. And the plist, is the list of attributes. And the now and comment are optional, and they are used for internal uses. Basically, what this is saying, if you want it now, it will provide the face specification as soon as this line is read. Otherwise, it'll wait until the theme is loaded. And then the comment will, should describe why you're doing it now. But both of these can be omitted, and they will be in the upcoming examples. Finally, there is a provide theme. And this provide theme declares that the theme is ready to be used. And that's it. Those are the 4 functions, and a lot of them don't really have much in them. So let's go back to Emacs and make a theme. So we have these guys here. Let me go here. Let's go to Emacs.d, themes, new theme, theme.el. It is important to name your theme file with this -theme, because otherwise Emacs won't recognize it as a theme. And dang it. New theme, el. Okay. So first up, we have def theme. And let's name this guy reset CM. Okay. With reset CM theme as the documentation. Custom theme set faces. I'm going to omit the variables, but because it's going to be blank. So you provide the theme. I just realized an error. So then we can start grabbing these themes here, or the faces from the scratch buffer. And we can do this. T spec. And so our comment face will be nothing. And you can go through and add those in individually. Then down here, provide theme, reset CM. And then you would do this for each and every face that you see here. And what this does, it removes the CM faces from your Emacs. So I won't bore you with typing everything in. I've already created this guy here. And I've included some more here. So these are all the faces that aren't even included in that given buffer, including some highlighting. So that is the compilation buffer. You'll see some highlighting a lot more. And I've alphabetized it. So that's basically how you would create a reset theme. So this is the theme that I use, and I've named it Easter Peaches because it's pastels and a lot of orange going on, the peach color. And you can see that the T spec, and then these are examples of the spec. So foreground, it has a variable called orange C, which I've defined up top here. And weight, some underline. I've given some specific fonts. So really anything that is within the attributes would be defined here. So. So that's basically theme definition. And really honing in on what colors you want, knowing what goes where is pretty important. So creating a theme template from that reset theme is actually pretty simple. Basically taking what we have from that, we can make quick improvements by making those spec form variables instead of hard coding. Like I shown in my personal theme, you can have variables at the top and use those instead, and then that way you can just swap out colors for a given variable instead of going through. So you can keep the faces that CM uses around within your theme, even if you're not using them. That way you don't have any mixture between the two from the CM layer and your given theme. So that way you can remove it. Keeping it around makes your template a lot more reusable as well, because in the future you won't have to go through that task of trying to figure out what faces there are. And to make things even easier, I created this CM file that is essentially a preview of common theme elements. So if we switch back here, so if I have, this is my light theme. So for instance, my class name is foreground color is midnight blue. And if I load this theme, if I could type theme preview CM, these are very common elements for a theme, and it shows each of them. So if I were to load up my second theme, this is going to get hard on your eyes probably. You can see that the common elements have switched to my other theme. And this is just nice for testing themes out. You can see what it looks like for really any of the elements there. So I would also recommend setting up a directory within your profile that houses all your themes. So you can load them without having to drop them into the GNU directory. Then you would add this line to your Emacs settings, and that way it would always load your themes no matter where you are, because you're using operator to handle your changes for you. So to recap, we talked about font lock mode, what a theme is and how to CM complicate it. Find a list of faces, create a theme, and then reuse, test, and load. So I see we're kind of closing in here, so let's breeze through this real quick. Did you know that you can interact with CET Designer directly through Emacs code that you write? For those of you that do know, I'd really love to hear how you're using this, but for those that don't, I'll step through real quick on how. Within the cmcompile.el file in base Emacs, there is a section header titled interact that has the function CM compilation interact stir no source. What this function does, it takes in a string S that is CM code and runs it. So examples, how many times have you had to grab your mouse, click into CET Designer and just press F5? Why leave your Emacs? Call what F5 does with this function as a string, pass it into CM compilation interact stir no source, and boom, Emacs can now rebuild your snappers. Or when you have new library buttons and you have to go into CET Designer and press Shift F5, call what Shift F5 does with this string. You can even use Lisp in between, to grab current buffer or file or package information or whatever. And notice here how I'm also calling profile code. So if you have profile code that does specific things, it's even more powerful. So for instance, this one compiles all below for my current package, and it grabs the current buffer package and uses that as a parameter for CM code. Pretty handy. So some more handy functions that I use regularly. Switch units. So core settings. You can call this with that sterno source to switch to inches or meters. You can clear your drawing with this new test. You can load your current save test with this. You can revert an already loaded drawing. Undo and redo. The application here is really limitless, but I would also recommend keeping as much code as you can in CM land when using this, because you can imagine if you're writing CM code in a stir, it can get pretty unwieldy sometimes. So. And there are some things that the CM Emacs layer does that we may not want happening, so I thought I'd end on a little hack. So using the knowledge that defun cares about the last registered function, we can use that to our advantage. So first, though, you should think about storing any overridden functions in a separate package. This will make it a little more memorable to you because this is something that isn't typically done. And it's kind of flying in the face of what CM Emacs is meant to do. But I typically use .emacs.d. This is a standard location in Emacs world for per user specific files for Emacs. So taking this nomenclature, you can add this directory to your profile. That way you know. And I personally use the name CM overrides for this. So name it whatever makes sense to you, but so whatever. Once you have the directory set up, you can drop in a new EL file, make a new defun that has the same name as a known CM list function that you don't want. I've done this for two different functions in particular because it kind of made me feel a little dirty doing it this way, but this was the only way that I could get it to work because of this function right here. This CM split two screen compilation, what this does is it splits your compilation window your compilation frame window pair off onto a separate frame. And when it does that, when it creates the new frame, it just arbitrarily sets the background color to gray 88. And this was wiping out my theme's background color. So basically what I did was I overrode this function to no longer do that. And I put it into my CM overrides package. So to sort of end, I've created a small starter pack, a package of files that comes with that reset CM theme, the theme template, theme preview.cm that I showed, along with my personal theme. It also contains a few extra packages like theme rotate. This is something that I got from an old Configura developer that basically rotates through your themes. It includes my Emacs settings, stripped down version for a lot more portable usage. And I also included the PDFs of the Emacs and eLisp manuals. And this package is going to be included in the dev conference repo that you should have all gotten access to. And it should be under the Emacs presentation portion. So with that, I'm almost out of time. So, oh yeah, that's the repo. I will open the floor to some questions.
Okay, had a couple questions come in. First one, what are some good learning materials to learn Lisp in order to create scripts in Emacs?
Ooh, yeah, that's a good one. So there is, oh, I'm blanking on the name of it. Uh, but you can't really go wrong with the manual. It's going to explain everything. It's directly from the source. But there's another one that I will have to make note of here, that I can provide a link to. But there's a website that I use that gives a lot more precise examples, and it basically uses the manual and like talks through each of the functions and things within there. So
Are you talking about the manual on gnu.org?
no, it's actually it's a different website that I use that has a lot more succinct examples.
I mean, you mentioned two. The first one was that.
Yes, yes. So I prefer like the PDF because it's searchable.
Oh,
Their
that makes sense.
website's a little outdated, um, but yeah. I do mean that manual there.
Okay, next question. I've had times when I added packages that caused crashing. How do I run Emacs and CT operator in debug mode to find the cause of the crash?
Great question. So there is something that I'll show. So at the top of my Emacs file, there is this. So this is a toggle, global toggle, that will spit out an error when you are running into problems. What this will do is it will open up like I believe it uses its own window to do that, but essentially this, just toggle the debug on error on, and it'll um, help you sort out hopefully what's going on. So
Trying to paste it here in the chat. I'm not having a lot of luck. There we go. Okay. Another question. Is there anything for customizing or manually controlling the Windows positioning sizes, etc. in Emacs? For example, the CM count buffer reposition resizes all windows in the current frame when we first run CM mode.
yes, there is. So I personally use the CM area of let's see. Um, uh, there is, and I'm trying to find it. So there are parameters set up for those CM functions that split to screen, and if we describe this function, nope, that's a variable. Split to screen compilation. So if we go and look at those CM functions, so there are parameters that it uses to determine where those things are, and I use those to control the frame splitting, positioning, etc. So for instance, top left, its height, its width. You could even give, the actual position of it. So I would suggest looking into this variable here, or really any of the other variables. If you want to go the route of using operator alongside of your positioning, that's really the way I've done it. So, but I'm sure there are ways to um, take control of that yourself as well. I just don't know off the top of my head.
Okay. Uh, I'm having the same issue where new windows don't follow my created theme. Are you including an example of how you did that override? I noticed similar issues when using CX52 or Control X52 to open a new window.
What is that? Control X52. So that runs frame el, which make frame command, which, yes, so I believe this is the same problem that I was running into because we have a post frame creation hook that CM has. So if so let me see. CM overrides. Okay, so I don't think it is the same one after all. But essentially, what I did was I renamed this entire function. This exists in Emacs base, but it looks like Control X52 is a native Emacs command. Yes. So then make frame. I mean, really all that's doing is making a frame. I want to say here. Yes, so you can register a post frame creation hook. That, I mean, that's what this function is used here for. That can load your theme. So what you would do is add to, let me see. So you would add to this list in your Emacs, you know, this guy here. Add to list. This guy, you know, your function name. So like load my theme, right? And then anytime you make a frame, that hook would get called. So I'd try that, and if not, just you know, you could ask me. We could figure something out.
And last one, could we reach out to you separately for specific Emacs questions relating to CM and customizations? I'm actually going to hijack this one before Caleb answers. Keep in mind, we still have our forum, which is a great place for things like this. Obviously, Caleb's one of our local experts on Emacs and tweaking it, but who knows what the community at large has come up with. It's always good to reach out and get support from our entire community whenever you can. And some of us internally even do monitor those forums specifically for stuff like that.
Yeah, if I see Emacs, my eyes light up. So in the forum, that is.
Okie doke. I think we're at time. We get yelled at pretty nasty when we go over time, so we're gonna have to wrap it up. But if anyone wants to stick around for a couple minutes, we'll be here for a couple minutes. But otherwise, I just want to thank everyone for your attention. We really appreciate it. We hope you enjoy the rest of the experience.